Welcome to a new episode of To the Stars and Beyond. In our last episode, we explored Venus, Earth's enigmatic neighboring planet. We examined its dense, toxic atmosphere, analyzed its extreme temperatures, and discussed the geological processes that have shaped its surface. Today, we turn our attention to our own planet, Earth. Not only is it our home, but it is also a unique celestial body with complex geological structures, a dynamic climate, and a fascinating history spanning billions of years. Together, we will explore Earth's special characteristics, trace its development through geological eras, and examine the history of humankind up to the present day. Join me on this journey as we uncover the secrets of our home planet and once again look to the stars and beyond. The historical significance and origin of a celestial body's name are often closely linked. Many planets, moons, and stars derive their names from mythology or are named after prominent figures in science. A prime example is the planet Mars, named after the Roman god of war, an allusion to its reddish color, reminiscent of blood. Similarly, the planet Mercury is named after the winged messenger of the gods, referring to its swift orbit around the Sun. Venus, too, was named after the Roman goddess of love and beauty, likely due to its brilliant brightness in the sky. Such naming conventions often reflect the characteristics or the prevailing perceptions of these celestial objects at the time. The name Earth originates from the Old English eorthe, meaning ground or soil. Unlike most planets in our solar system, which are named after Roman deities, Earth's name developed from everyday language. Many languages have similar terms, such as the German Erde or the Dutch Aarde. These names stem from Germanic linguistic roots and reflect humanity's deep connection to its environment. Historically, Earth was long considered the center of the universe in many cultures. In ancient times, it was often depicted as a flat disk surrounded by water or enclosed within a celestial sphere. Only with the discoveries of astronomers like Copernicus and Galileo did the heliocentric model gain acceptance, positioning Earth as one of many planets in our solar system. Yet, Earth remains unique to us, not only as our home, but as the only known place where life exists. Earth is the only known planet to support life. This is due to a unique combination of factors: an atmosphere containing oxygen and nitrogen, large amounts of liquid water, and a stable orbit around the Sun. About 71% of Earth's surface is covered by water, setting it apart from all other planets in the solar system. Oceans play a crucial role in regulating the climate and sustaining life. Another remarkable feature of Earth is its magnetic field, generated by the liquid outer core. This magnetic field protects Earth from harmful cosmic radiation and solar winds. Additionally, plate tectonics continuously renew the Earth's crust, contributing to atmospheric stability and the long-term evolution of life. Earth's atmosphere is also unique. It not only contains the gases necessary for life, but also shields the planet from meteoroids and regulates temperature through the greenhouse effect. Without these protective mechanisms, Earth would be a hostile environment. Earth features an impressive variety of surface structures, from vast mountain ranges to deep ocean trenches. Mount Everest stands as the highest point on Earth at 8,848 meters, while the Mariana Trench reaches depths of about 11,000 meters, making it the lowest point. These extreme elevations and depths are the result of tectonic movements that have shaped the Earth's crust over millions of years. Another fascinating aspect of Earth's surface is its vast desert regions, such as the Sahara, the world's largest hot desert, and Antarctica, which is considered the coldest desert. These regions experience extreme climatic conditions, yet provide unique habitats for specialized plant and animal species. Beyond these natural extremes, there are numerous world-famous locations of cultural and geological significance. The Grand Canyon in the USA, Victoria Falls in Africa, and the Great Barrier Reef in Australia are just a few of the Earth's spectacular landmarks. They attract millions of visitors each year and hold immense scientific and ecological value. Earth formed approximately 4.54 billion years ago from an accretion disk surrounding the young Sun. In its early phase, it was subjected to intense bombardment by planetesimals, releasing immense amounts of heat. This led to planetary differentiation, where heavy elements such as iron settled into the core, forming a layered structure with crust, mantle, and core. During the Hadean Eon, the Earth's surface was extremely hot and covered with magma. The first oceans may have formed from the condensation of water vapor released from the Earth's interior. In the Archean, around 3.8 billion years ago, the first primitive life forms emerged, likely chemosynthetic bacteria thriving in hydrothermal vents. Oxygen levels, however, remained extremely low. During the Proterozoic Eon, from 2.5 billion to 541 million years ago, the so-called Great Oxygenation event occurred, triggered by cyanobacterial photosynthesis. This led to the oxidation of dissolved iron in the oceans and the accumulation of oxygen in the atmosphere. This era also saw the emergence of the first eukaryotic organisms, paving the way for complex life. The Phanerozoic Eon, which began 541 million years ago and continues to this day, is marked by an explosion of biological diversity. The Cambrian period saw the emergence of nearly all modern animal phyla. Over subsequent geological eras, including the Paleozoic, Mesozoic, and Cenozoic, plants, vertebrates, and eventually mammals and birds evolved. The Cretaceous-Paleogene boundary, 66 million years ago, marked the mass extinction of the dinosaurs, allowing mammals to become the dominant life form. Human history began in the late Cenozoic. Around 2.5 million years ago, the first members of the genus Homo emerged in Africa. Homo sapiens appeared about 300,000 years ago and spread across the globe. The Neolithic Revolution, approximately 12,000 years ago, enabled the transition from hunter-gatherer societies to agricultural civilizations. With the rise of civilizations, writing, and technology, humanity entered a phase of rapid cultural and scientific advancement, leading us to the modern era. In 1 billion years, the Sun's increasing luminosity will significantly raise Earth's surface temperature. The oceans will evaporate, causing the collapse of the hydrological cycle. Without water and with rising temperatures, Earth will become uninhabitable for complex life. Geological activity may decline as the Earth's core cools, eventually halting plate tectonics. In about 2 billion years, atmospheric oxygen levels will drop dramatically. This occurs as increasing solar radiation accelerates weathering, reducing CO2 levels and severely limiting photosynthesis. Only extremophilic microorganisms may survive in isolated niches. In 3 billion years, Earth will continue to heat up, and the last water reserves will evaporate. Tectonic activity will likely come to a near halt, stopping carbon and other elemental recycling processes. The crust will become increasingly fractured and inhospitable. In 4 billion years, the Sun will begin expanding on its path to becoming a red giant. Its radiation will become so intense that Earth's atmosphere will escape into space. The surface will resemble a furnace, making any form of life impossible. In 5 billion years, the Sun will reach its red giant phase. Its volume will expand so much that it will engulf Mercury and Venus. Whether Earth survives or is also consumed depends on the Sun's precise mass loss rate. Even if the planet remains physically intact, it will be a scorched wasteland. In about 6 to 7 billion years, the Sun will shed its outer layers, forming a planetary nebula. What remains is a white dwarf, a dense, extremely hot core that will gradually cool over time. Earth, if it is not destroyed, will be a frozen, dead rock orbiting this remnant of a star. That concludes today's episode of To the Stars and Beyond. We have explored the fascinating history and evolution of our home planet, from its formation to the present day. But our journey through the cosmos continues. In the next episode, we turn our attention to our loyal companion in the night sky, the Earth's moon. We will delve into the moon's origin story, examine its geological features, and explore the crucial role it plays in Earth's natural systems. Additionally, we will take a look at past and future missions that continue to expand our knowledge of the moon. So stay tuned and join us next time on our journey to the stars and beyond.